All right, so yesterday we did the quiz. Today we are moving on to transformations. You'll notice in green here, we're going to have our next test on next Friday. Hopefully you know that there's a 3-day weekend coming up, so I won't see you Monday. So today and tomorrow is notes on transformations. Tuesday, Wednesday of next week are notes on dilations specifically, and then Thursday, Friday of next week is review and test. Okay, that's coming up. So let's talk about transformations. Look at this smiley face. Did you draw it? Or whatever shape. And then you want to try to sketch 3 different transformations. One of them is rotation. Okay, so rotation is when you turn. There we go. Pen was not working. Rotation, and it's still not working. Okay, here's an example of rotation. I'm going to rotate it clockwise. Y'all heard that word before, clockwise? Like the hands on an old school clock, they go. So this, if I turn it, basically, it's going to look sideways. That's a rotation, right? My pen is messing up really bad. Rotation. Another one you can do is, if you have a line, you can reflect across the line. So if I take this smiley face, go across that line, it's going to look upside down. That is a reflection. Cool. Rotation turns it, reflection flips it, some direction, and then that was reflection. The last one is to translate. A translation just shifts it over. It's the same exact, it looks the same. It's just been shifted, moved over, up, down, left, or right, or some combination. Okay, that's it for the warm-up. Those are the 3 we're going to talk about today, but to do it on the coordinate plane, which is a graph, you're going to have to use some rules. So let's talk about this. All we're going to do are 4 examples, and then I'm going to give you the assignment that we're going to work on tomorrow. There are rulers around because you're going to be sketching some lines, so here we go. So everyone look at this side of the paper. So I need everyone locked in here because I'm going to explain what this is. I know it's just a bunch of stuff on a paper right now, but I need everyone to look. So, hey, look over here. Everyone's looking. Like, looking with your eyes. Look. All right. So the first one, translation. From our warm-up, we said it's when you shift, right? So if you're going to shift some points, x comma y coordinate points, what you're going to do, if you look off to the right here, is you're just adding or subtracting from the numbers, okay? Does everyone know that adding to an x moves it to the right, right? Positive numbers go to the right. What kind of numbers go to the left? Negative, right? Does everyone know this? Positive is right, negative is left. And what about up and down? Up is positive, down is negative, right? So all you're doing is adding and subtracting the x's and y's to get a translation. I'm going to show you an example on the back, but I'm just going over that. Now real quick, reflection, okay? Do you see the different reflections here? You can reflect across the x-axis, it looks like this, left and right. You can reflect it across the y-axis, up and down. There's 2 other reflections. Now this says reflecting across y equals x. Off to the right, can you draw this for me? Oh. Y equals x looks like this. Okay, draw that please. When I say reflect over y equals x, I'm telling you to reflect over this diagonal line. So you can actually reflect diagonally, okay? And just so we have the other one, y equals negative x is diagonal the other direction. So you can reflect and flip over these diagonal lines, y equals x or negative x. Okay? Now, I want you to see the rule. All of your original points are x comma y. But look right here. X, y becomes something else. So for an x-axis reflection, who can tell me what changed? XY becomes x negative y. So what's the only change you see right here? The negative, right? That means you change the sign. Positives become negatives, and negatives become positives, okay? Only the y value changes. Okay? So if I give you a bunch of numbers of x, y's, you would know just change the y sign. Okay, next one. For the y-axis, the only thing that changes is the x sign. Okay, so I know I'm just giving you rules, but when we flip it over, I'm going to show you how to use it. Okay, but what about y equals x? Who can tell me what happened? Right here. xy becomes yx. What's the change? If xy becomes yx, what's the only thing that changed there? Yeah, flipped, right? Just change the order. That's easy. What about y equals negative x? This one's weird. You change the order, and they both change the sign. Okay, so those are the rules for reflection. Stay with me. Rotation. This is where it gets a little weirder. Okay. Now, does everyone know? Hey, does everyone know what clockwise is? I'm holding this. Clockwise is going to go this direction, right? A clock turns this way. It's like it's going to the right. Cool. Counterclockwise goes the other way, right? So look at this. 90 degrees counterclockwise is the same thing as 270 degrees clockwise. Let me show you. Look, watch my harvesting tool here. Ready? 90 degrees clockwise goes, it stops right here, pointing that way. 270 degrees counterclockwise stops right here. It's going the same direction. Okay, so these two have the same rules, whether you go 90 degrees clock or 270 counterclock. So I want you to know, when you're reading the problems, make sure you see which one it is. Because if you see 90, it could be this one, counterclockwise, or down here, clockwise. You see how there's two different 90s? You got to look for the words, counter or clockwise. Okay? Now, what's the rule? xy becomes negative yx. What are the two changes you see from xy to negative yx? They switch the order, and then the y value changes the sign, right? So you know how to use the rule. I'm going to show you on the back anyways, but 180 degrees, both x and y change their sign. 270 counterclockwise, they switch, and x changes the sign, okay? And then dilations, we're not doing dilations today, but you would just multiply x and y by a number, okay? We'll do that next week. Okay, flip it over. We're gonna look at how we can do these problems together. Now, number one, all the problems today and tomorrow have to do with graphs, okay? You gotta know how to graph a point or how to tell me where a point is on a graph. A lot of us, or some of us, might struggle with x and y. Which way is x, which way is y? So let me just tell you real quick. Look, this is x, left to right. This is y, bottom to top, okay? Does everyone know negative is left, negative is down? Those are important things you gotta know, okay? Now, look at this. We're given a picture. This is EPRM, four-sided figure. It says to reflect it over the x-axis, sketch the new shape, fill in the points. Now I'm going to tell you how to do all these step by step. Step number one, I need to write down these original points, okay? I can't figure out the new points unless I know the original points. So you see this space right here? I'm going to write down the original points. EPRM. Let's go ahead and do that together. Here we go. go ahead and write EPRM. We're going to write down the original points. Cool. Hey, write this down. Everyone's writing this down. Now, who can tell me the coordinates of E? Let's start with E. On the graph, here's E. Now, if you struggle with this, this is the best way I can tell you to do it. Put your pencil at the origin, right in the middle. Okay? And which way do you go, left or right? Don't go up and down. Left and right, which way goes to E? Is it left or right to get to E? Right 2. We know right is positive, so it's going to be 2. And now you go up and down, up 1, right? So what's the coordinates of E? So this is positive 2, and then positive 1. Because right is positive, up is positive. Okay, positive 2, positive 1. Let's write that down. Every time I need to use this pen, it does not work. Okay, there we go. 2, 1. This E is 2 to the right, up 1. 2, 1. Okay? What about P? So starting at 0, 0, P goes which way, left or right? Right 1 is positive 1. Does it go up or down? So that's 0. Okay? So right 1 doesn't go up or down. That's 1, 0. Okay, you got to be able to write down points. What about R? So this goes to the right 1, down 1. What are those coordinates if it goes right 1, down 1? What? So the first number is positive or negative? Okay, this is hard to hear you. Is this 1 or negative 1? Positive 1, and what's this one? Negative 1. Okay, 1, negative 1, because it goes down. Okay, so here we go. 1, negative 1. What about M? So starting at 0, it goes 1, 2, 3, 4 to the right. 1, 2, 3, 4 down. What should I write? 4, negative 4. Okay. Now, so far, all we've done is step 1. Step 1 is write down the original points. Cool. Don't write them in the. You have the original points. Now, here's step 2. What are they asking us to do? What's the first word right here? Reflect, right? Now, reflect what? Which way? So keep reading, reflect over what? It says x-axis, right? Cool. So reflect over the x-axis. Let's go back to the front page. What is the rule to reflect over the x-axis? So here's the word reflection, here's the word x-axis, and then the rule is right over here. X, negative y. Does everyone see the rule right here? So the rule for reflect over x, x, negative y. I'm going to write that down at the top here. Now what's the change? What's the only change if it goes from xy to x, negative y? What changed? From xy to x, negative y. What do y'all think? So they actually don't switch. X and y are in the same position. But what's the y has a negative? That's the only change, right? Which means you're just changing the sign of the y. Cool? So I'm going to make a little note here. You're going to change the sign of y. Okay, so look at your 4 points. All of these y values, the x values stay the same. The y values have to change. So positive 1 is going to become negative 1. 0, there's no such thing as negative 0. It just stays. That's a weird one. Negative 1 becomes positive 1. Negative 4 becomes positive 1. Okay, so we're going to fill this in. So again, all these x's stay the same. 2, 1, 1, 4. X's stay the same, but the y's change their sign. Positive 1 becomes negative 1, 0. Negative 1 becomes positive 1. Negative 4 becomes positive 4. Okay. Now, that was like step 3. Step 1, write the original points. Step 2, get your rule. Step 3, apply the rule to get the new points. If you stop here, that is not the answer. Okay? Whenever we do a transformation, I want to see it on the graph. So your last step is you have to graph this. Look right here. It says the word sketch. That means put it on the graph. Okay? So now I'm going to take these new points, put them on the graph. So 2, negative 1 means put your pencil at 0, 0 in the middle. Is everyone looking over here? Hey. 2, negative 1, starting at 0, you go 2 to the right. Negative 1 means down 1. 2, negative 1. That's my new E. So I'm going to write E with a little apostrophe. That's the way you say that is E prime. Okay, so this is my E prime. The next one is 1, 0. Starting at 0, 1, 0. Okay, is P prime. 1, 1 goes right 1, up 1. That's my R prime. And then M prime is 4, 4. Okay. Make sure you've got these new points. Make sure you graph these new points. And part of this last step is to actually connect them and make straight lines. So there were rulers you could have grabbed on the way in. Maybe they're near you, but you can make nice straight lines when you're doing this. So let's go ahead and connect all 4 of those points. Cool. Doesn't that look like it was reflected across the x-axis right here? Right? Up and down, it was reflected. Because I got the original points, I wrote the rule, I applied the rule, and then I graphed it. Okay? I'll give you a second. Make sure you got that down. We're going to do number 2. Okay? Does everyone have number 1? Y'all ready for number 2? All right, look at number 2. Here we go. Number 2. All right. Let's write the original 3 points, B, D, and X, right here off to the side, B, D, X. Okay? Who can tell me the coordinates of B? You with me? All right, so it goes from starting at the origin, it goes to the right 1. It doesn't go up or down. So B is 1, 0. Right 1 doesn't go up or down. So 1, 0. Letter D, okay? Now this one's tricky. For letter D, it does not go left or right. So what's the X value of that? If it's on the line, if it didn't go left or right, what's the x value right there? 0. And then what's the y value if it goes down 3? 3 is up. But if it goes down, that's -3. So 0, -3 for D. And x, what's the x and the y? What do y'all think? Look over here. What's the x and the y of x? 4, -1, because it goes down. Okay, very good. All right, so that's step 1. Write your points. Step 2, what is the transformation? What does it say right here? First word. Rotate. How much do we rotate? Which direction? Rotate what? What does it say? Okay, 90, and then also which direction? It says 90 counterclockwise. Remember, there's two 90s on your rules. One is counterclockwise, one is clockwise. So let's go back to find the rule for 90 counterclockwise. So look, this one says 90 clockwise. That's not it. 90 counterclockwise. That's the one that I want. Okay? So that's a rotation, 90 counterclockwise. What's the rule? What two things are happening right here, this rule? What do y'all think? XY becomes -YX. You switch the order, and the Y value changes the sign. Okay? So I'm going to write that rule, -YX, on number 2. And here's my 2 steps. Step 1, change the sign of Y. You have to do that first, and then you can switch the order. You change the sign of the Y, then you switch the order to get the new point. Right? So we wrote down BDX, we wrote down our rule, now we're going to use that rule to find the new point. Right? So let's do it. First, let's change these Y values. So 1, 0, the 0, you can't change that value, right? -3, though, for point D, -3 will become a +3. -1 will become a +1, and switch them. So change these Y's and switch them. So who can tell me the new B? What's it going to be for B prime? What? Change the Y sign, flip it. What's it going to be? 0, 1 is correct. What about letter D? 0, -3. Change that -3 sign and flip it. What's it going to be? +3, 0. Very good. Last one, if I change the -1 to a +1 and flip it, it'll be 1, 4. Cool? All right, so let's graph it. Don't forget to graph it, okay? 0, 1, put a point. Okay, that's my B prime. 3, 0, put a point. B prime. 1, 4, put a point. X prime. And again, you have a ruler you grabbed on the way in, or you can grab one nearby, so you can make nice straight lines. Now, doesn't this look like it's been rotated 90 counterclockwise? Kind of follow the triangle it's been. Rotate 90. That's good. We wrote down the points, we wrote down the rule, we applied the rule, we graphed the points, and then you look at it and think, does that make sense? It does make sense, okay? I'll give you a second to make sure you have number 2 down, so that way we can Move on to 3. You turn it. Ready for 3. Anyone still need number 2? Nobody? All right, everyone, look over here. So number 3. Once again, now here's the deal. I went fairly slow on 1 and 2. With number 3, we're going to write down these points a little faster. But stay with me. Heads up. Everyone's looking over here. Okay, if you got a phone in your hand, put it away. So AKMD. Go ahead and write down AK. There. Okay. AKMD. Now everybody, if I put my pencil at 0, 0, to get to A, I have to go 1, 2, 4, 1, 2, 3, 4 to the left. Sorry, 1, 2, 3 to the left, and then 1, 2, 3 up. Do you know the coordinates of 3 left, 3 up? What is that? Negative 3, 3. Does everyone know that left is negative? You have to know that. If you miss a negative sign, it's going to mess your whole problem up. Okay, be careful. K goes 3 to the left, but it goes up 5, so it's negative 3, 5. M goes left 1, up 5, negative 5. The letter D is on the axis. It doesn't go left or right. So that's 0, and then up 2, it's 2. Okay, make sure you have these 4 points written down. And then we're going to see what's the transformation. What's the very first word? Translate, which means shifted. And it tells us which way. It says translate 1 left, 4 down. Now, if you remember, when you're shifting it, you're just adding or subtracting from the x and the y values. So let me show you where it is on here. Translation, you're just going to add or subtract the x and y values. Okay? Let me show you. Now, let me put it this way. You could take that graph, and when it says 1 left, 4 down, you could take every single point and go 1 left, 4 down, put a point. 1 left, 4 down, put a point. Right? You can literally move every single point that way. That works. And then fill these in. I'm going to do it the mathy way, the algebraic way. Let's write this down. My rule, if it says 1 unit to the left, is that plus or minus? Which way is left, plus or minus? Minus 1 to the left is x minus 1. And then y, when it says 4 units down, is that plus or minus with down? Minus, so y minus 4. So here's what we're going to do. We're going to subtract 1 from the x's and subtract 4 from the y's. Right? That's what this means. Subtract 1 from every single x. Subtract 4 from every single y. So you could either do this on the graph by shifting points, or you can do it mathematically by taking all those coordinates, x and y values, and subtracting using the rule we just wrote. So I'm going to do it the mathy way. I'm going to take every x value and subtract 1. So negative 3 minus 1 is negative 4. Negative 3 minus 1 is negative 4. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. And all my y values, I'm going to subtract 4. So 3 minus 4, negative 1. 5 minus 4, 1. 5 minus 4, 1. 2 minus 4, negative 2. So again, I subtracted 1 from every x, I subtracted 4 from every y, and now I can plot these new points. Negative 3, 3, negative 3, sorry, negative 4, negative 1 goes here. Negative 4, positive 1 goes here. Negative 2, positive 1 goes here. Negative 1, negative 2 goes here. Use your ruler to make some straight lines. Alrighty. Doesn't that look like it's been shifted 1 to the left and 4 down? It does. So I'll give you a second to make sure you have number 3, and then we'll show you number 4 real quick, and I'll be done. All right, is everyone ready for 4? All right, last one, stay with me. Number 4, let's write these points down. H, N, V, Q. We're gonna write these down a little faster. It's over with. H is 4 left, 2 up. That's negative 4, 2. N is on the line, up 3, so that's 0, 3. V is right 2, up 2, that's 2, 2. Q is 3 left, and that's it, so negative 3, comma 0. Write those down, please. All right, now, what is the rule? It says to reflect over what? What are we reflecting over? What line? Not just y, what does it say? Y equals x. Y equals x. Remember that rule? Look. Right here. Reflect y equals x is this rule. xy becomes yx. Write this rule real quick. To get from xy to yx, all you're going to do is switch the order, right? So let's do that real quick. Negative 4, 2, switch the order. 2, negative 4. 0, 3, 3, 0. 2, 2 stays the same. And then 0, negative 3. Real quick, y equals x is a diagonal line going up 1, over 1, up 1, over 1. So you want to know what that looks like. It looks like this, okay? This diagonal line is y equals x. So if you plot these new points, 2, negative 4, 3, 0, 2, 2, 0, negative 3, and if you connect all 4 of those points, doesn't it look like the original is reflected across that diagonal? Right? Does everyone understand that you have to have a graph? If you don't put the graph, you didn't transform it, okay? Now, I'm going to pass out the assignment, but tomorrow you will have time to work on this, okay? I know today's a little shorter because of lead time. Make sure you have this down, okay? I'm going to zoom out so you can see all 4 of these in case you didn't get them, okay? Make sure you have all this written down. It's up here on the board, okay?